Everybody,
now, if you were here for the opening remarks,
my name,
that was my cell phone that went off really loud. So
I remember the first one.
As punishment, if anyone wants to play a ringtone really loud at any point during my talk, that is well deserved.
Good to be here.
Welcome.
If you didn't hear,
so a little bit about who I am. I'm Nick Ascoli. I'm the founder and CEO of a company called Fortrace. We're an external attack surface management product. Formerly, I was a senior cyber research scientist with a company called Security Risk Advisors. I've made some open source tools, all very OSINT-y, and I've spoken at a bunch of conferences. And if you'd like to talk or want to chat about this kind of stuff, that's my contact information.
It's a great organization.
I'm pretty new to Twitter, so don't expect much over there.
With ICS,
now, equally as important to this topic is who I am not. First and foremost, I am not a plumber.
I believe, hopefully,
though
really
I have been known to find some leaky buckets. I cannot be trusted with anything blue collar beyond
like ICS,
putting together IKEA furniture.
And vulnerabilities.
I'm also not a lawyer.
My topic
While this is a strange disclaimer to have to give for a talk like this,
I was going to present onward some of the themes that my team sees.
The legalities of accessing someone else's documents from the public internet,
as well as the previous couple years,
messy at best. There's not a lot of litigation beyond a couple small examples I'll talk about, but we're going to be talking a lot about Google dorking, finding documents on the internet from the comfort of your own home and the legality around viewing those files.
Pipedream.
In short, I do not endorse viewing someone else's files without their permission. However, it's very easy to do. Now, this slide you might find offensive due to its simplicity, but when I'm talking about documents in this talk specifically, these are the kinds I'm talking about. The file types that spin the cogs of the world of business. These are the files that we interact with. These are typically the file types we're trying to protect as enterprise defenders from getting out. These are the files that store everything that a business is doing. Now, in terms of publication, I break publication down into two categories. The least common one is intentional. This is, releasing marketing collateral, releasing product documentation as a company.
The most sophistication that these activity groups have tracked and demonstrated, and it's mapped to the industrial control systems cyber kill chain. So if you're familiar with the traditional cybersecurity kill chain, it's a series of steps. I think it's 7 steps from initial delivery all the way to exploitation or action on objectives. And so we would consider that stage 1 of gaining access in the environment, gaining persistence, and then the action on objectives would be moving on to stage 2, which is gaining access into the industrial control systems environment. From stage 2, you're developing a capability, you're reconning what the industrial control systems look like, and then you're disrupting or having some sort of effect on the industrial control systems environment. The vast majority of the activity groups that we track, represented by those little coins there, are what we would call ICS curious stage. So they've started attacking and gaining access into the IT environments for various asset owners. They've started doing reconnaissance, attacking suppliers, vendors, and OEM providers for some of these environments, but they haven't actually gained access into the industrial control systems environments. What's interesting there is, unlike in the IT space, the ICS space is much more selective, and they're in a much more of a growing of a capabilities perspective. And so it's interesting watching them from the early days of gaining that capability or understanding that they need that capability, doing that recon, doing that capabilities development, which is where the vast majority of these activity groups are. And then it starts weeding out from there. So the next category there of stage 2 is essentially activity groups, adversaries that have gained access in the industrial control systems environment, but they haven't done anything there. But they're actively collecting data, they're exfiltrating information, and they're positioning themselves within those environments for a later date, whatever later date that may be. And then the creme de creme is the stage 2 on the action stage. So these 5 activity groups have demonstrated some sort of capability to disrupt and impact industrial control systems. This ranges from Electrum, responsible for 2016 Ukraine attack against transmission that led to a power outage in Kiev, to Xenotime attacked a refinery in Saudi Arabia with a piece of malware called Triton, also known as Trisis, that tripped that refinery several times and actually could have led to a safety event for the personnel there. They actually targeted the safety systems of that refinery in order to trip that refinery. So that's the level of sophistication that we're speaking to when we talk about adversaries that have stage 2 capabilities. And now we're tracking a new one as of a couple weeks called Chernovite. So Chernovite has built a go to the next slide. Chernovite has built a toolkit that we dub Pipedream. Amania also refers to it as InController, if you've heard of InController. And Pipedream is notable in that it's only the 7th malware that has been developed that has ICS capabilities embedded into it. So think of all the malware strains out there that you may be familiar with. There's only 7 that can impact industrial control systems that are known. The last that I mentioned was Triton, also known as Trisis. That was deployed in 2017, and it was discovered in 2018. So you're talking about something that is continuing to escalate as far as these capabilities are being developed more and more, but it's still a 1, 2, 3 year sort of time frame for some of these toolkits to be discovered, and that's what's unique and a unique opportunity to truly dive into them and understand what the new capabilities are. So Chernovite is the threat group that we associate with building Pipedream. They didn't actually deploy or activate Pipedream that had a effect that we're aware of within the world, and it looks to be that a lot of the cues in there are towards targeting liquid natural gas facilities, and I'll speak to that through some of the targeting that they illustrate with their tool set. But the important aspect there is how these toolkits were developed allow for a much broader range of being able to deploy this tool set. So it would be very simplistic to say, oh, well, I'm not in the LNG vertical, so I don't need to worry about that. I think would be the wrong takeaway when you're looking at the Pipedream capabilities itself. What Chernovite and the Pipedream software targets are a range of PLCs, so program logic controllers. These are, again, something that you could see at the ICS Village if you stop by there later today. But they're really just dumb little computers. If you haven't had a chance to touch a PLC, they're taking input and they're doing some logic on that input, and then they're doing some sort of output. So input may be sensing the volume of liquid in a tank, and then the logic identifies that tank is full. So the output, it turns off a valve to stop filling up that tank, as a simple example of what a PLC would do. The Pipedream kit is focused on affecting these range of embedded devices. So Omron PLCs, Schneider Electric PLCs, and some of the software associated with that. But again, one of the takeaways is while that software is configured to target these, there's nothing to suggest that you can't load in another configuration and target a much broader set of PLCs. So again, the takeaway isn't, oh, I don't have the Schneider TM251, so I'm good. The takeaway is actually some of the underlying software that it's affecting that I'll talk through, such as CodeSys, is applied in hundreds of vendors' PLCs and thousands of different makes and models. So the scope of this is much larger than just what's on here. The software itself is focused configuration-wise on these devices. So I'm going to step by, there's 5 tools that are embedded within Pipedream. Pipedream is more of an overarching term for each of these binaries. And as I walk through here, you will kind of set the stage for what these attack sequences could look like using all of these tools. We don't think they were designed in a way that they're used sequentially. It's more of a key chain of sorts that the adversary would have in order to leverage that as needed. And they could also be used independent of each other, ultimately. The first one, dubbed Lazy Cargo, is really focused on your more traditional enterprise network environment. It's essentially the dropper that is used by Chernovite, and the dropper itself is using a known exploit. I don't have the CVE. The CVE is 2020-15368, which is a signed binary. It's a driver for motherboards. It'll work on any PC though. It's not particularly focused on any motherboard. And that signed driver allows for remote code execution for unsigned binaries. So it's essentially the dropper that Chernovite uses on Windows hosts in what you would traditionally think of as the delivery and exploitation stages of the ICS kill chain. And then the next tool is dubbed Dust Tunnel, is really the C2 mechanism, the persistent mechanism that would again be deployed in a traditional IT environment or higher up in the various levels of the ICS environments where the system operators, the engineers would be working on traditional Windows equipment. And then it gets a little bit more unique from there. So OPC UA is a protocol that is seen in industrial control systems environments. It is a translation protocol. So if your human-machine interface, which is ultimately like an operator machine that is accessing, getting data points from a PLC, it may not understand the proprietary protocol of that PLC. The glue between that is OPC that will have a driver for that protocol and to speak to that HMI. So it's really like a translation mechanism that's used by OPC. And there's kind of 2 paths here with using Mousehole with OPC UA. One of them is certainly just reconnaissance of identifying OPC UA servers, enumerating the equipment that are behind those servers and understanding some of the tagging information that would be behind there. When I say tag, it would be a particular I/O point on a particular controller might be tagged as tank 1 as an example. And if you access that tag, you're talking about the data value that's behind it. So it's 500 or 1,000, or you can manipulate that tag and turn it to 0, which would have a downstream effect to that device. What's notable with OPC is the predecessor to OPC UA is OPC DA, which is a older protocol doing the exact same thing. It's actually based on OLE from if you're from back in the day with Windows 3.1, Windows 95, you had object linkable, what does it stand for? Object link embedded pieces of code, and OPC DA is based off that, which is to say very insecure. But regardless, OPC DA was used in the Ukraine 2016 attack in Ukraine that led to a transmission substation outage. By crash override, also known as in destroyer, that basically changed and turned on or opened breakers within the substation, whereby de-energizing the lines within the substation. Mousehole is interesting in that it takes that idea of the attack, but it extends it into a new protocol, a more modern protocol, and adds a little bit more sophistication, more depth and understanding of that protocol rather than the simple one kind of encoded binary or encoded packet that the crash override would send out. This is a much more deep understanding of that protocol itself, which ultimately allows for mouse hill to not only communicate with these pieces of equipment, but also change settings within that equipment. Now that's interesting that you may assume that allows for a great effect within these industrial environments, whether it's a substation or a LNG facility. But without understanding those pieces of equipment, how they operate, and the industrial control systems process itself, it's kind of just spraying and praying at that point. You need to have a solid understanding of the engineering aspect that's behind the industrial process in order to have a larger effect. So that's Mousehole, the first kind of tool that's really focused on developing a capability within the ICS environment, and optionally giving the attacker some ability to execute the attack with the right prerequisite knowledge that's embedded in that facility. Moving on to something a little bit more sophisticated, Evil Scholar is the next tool set. This is a framework that's actually in Python. Because of some of the libraries it uses, it only runs on Linux hosts. You can think of it more of something like Metasploit, where you have a shell capability to actively interrogate, manipulate, and change the states of the Schneider Electric PLCs. It's interesting in that it has a lot of capabilities in the back end. So this wasn't something that was whipped up very quickly. It has support for 3 different protocols. 2 of them are proprietary protocols, and it's not simply replaying a packet. It is the library that is within Evil Scholar is a fairly robust implementation of the protocol at the end of the day. So the first one, Schneider Electric broadcast protocol, essentially, as it sounds, is broadcasts to the broadcast domain looking for Schneider Electric devices. So these PLCs or devices will respond back when receiving this broadcast. So that's identifying all those pieces of equipment. The next protocol, the CodeSys protocol, which rides on the 1740, is going to then provide enumerated details of that PLC. So what is the model number? What is the make? What are the cards within the backplane of the device? And some of the other auxiliary information thereof. And then Modbus is actually a less sophisticated implementation in Evil Scholar. Is basically a open source library called Modbus that you can find on GitHub, and they did some extensions of that library itself. But Modbus is a protocol that is widely used, has been around since before the internet. Before Modbus, it was a implementation on serial devices, and then that serial protocol moved its way to Modbus, and it allows you to read and write variables from the memory space of the PLCs. And I'll get into an example of how that can be used shortly. Ultimately, Evil Scholar represents a robust sort of framework for the adversary to, once they have gained access into these environments, to explore the environment, understand the environment, and develop capabilities around the Schneider Electric PLCs. It does have full file system access to these devices, so it can modify files on the PLC. It can look for files and list files, download files. It can do denial of service. It can crash. It can wipe the memory of the PLC. It has full capability towards there. One of the features it does have that makes it exceptionally unique is the ability to proxy. So one of the focuses of industrial control systems or for the threat actors is ultimately understanding the name of the game, which is once you have access in the environment, you can largely do whatever you want. So defenders focus on segmentation and removing that carte blanche access into these environments, which means firewalls, lots of firewalls in lots of places. The evil scholar actually can route through a firewall to a PLC and then use that PLC to send traffic to other PLCs. So that a very traditional sort of communication structure would be an engineering workstation, which is what would program a PLC, would have legitimate access to that PLC. So there'd be authorized communication, even if there were a firewall to communicate to that device. And Evil Scholar uses that to his advantage to then also embed commands and send them to other devices in the next layer down that the engineering workstation would not have access to. So if the adversary is looking on gaining access to other parts of the network beyond what the firewall allow them to do, this would allow them to tunnel and have that capability, which is unique and something that certainly is new from a threat model perspective that the industry hasn't fully grappled with yet. Next up is Bad Omen. So while Evil Scholar was focused on Schneider Electric PLCs, Bad Omen is focused on Omron PLCs. This is essentially what's interesting about the industrial control system space is with IT, you're used to Linux and Windows and Cisco. In the ICS space, you have hundreds or really even thousands of OEMs that are producing software. Some of them are on Linux, some of them are on embedded Windows devices, but the make and model numbers are so great. So Omron is just another manufacturer that has their own implementation for PLCs, and Bad Omen is targeting that PLC device. A number of years ago, I guess like 15 or 20 years ago, PLCs started adding web servers to their PLCs from an administration perspective, similar to how your router may have a web administration interface. And this is what Bad Omen takes advantage of. So Bad Omen actually uses the CGI interface off a web server that's listening on the Omron devices, and all of its functionality is based on exactly that. This tool, Bad Omen, looks much more dev-friendly, and that it can take packet captures from its tool. It can enumerate the file system. It has the ability to implant binaries within the PLC itself, so think like rootkit sort of behavior on this embedded equipment. It has the ability to take backups, to restore backups. It has the ability to change the program logic that's on the PLC and be able to tamper and wipe with the memory of the controller itself. So carte blanche access to really manipulate the Omron PLC itself. I don't have time. I need to speed up a little bit. This is a bit of what the communication structure looks like on the CGI interface as far as it's just HTTP. It's sending HTTP commands to a CGI asking for a set structure of changing the program mode and then clearing the memory and then resetting the controller and then putting it to a run state, which is it's empty at that point. So it's a brick if this series of if the wiper aspect were implemented. And again, this is command line interface, like shell sort of prompt where they have a set commands and they're just issuing them to the devices, not unlike Metasploit. So the attack scenarios, if you were to stage these together, really what you're looking at is a series of tools that could be deployed in stage 1 of the ICS kill chain as well as stage 2. Lazy cargo and dust tunnel are really that initial delivery and exploitation piece within either the traditional enterprise network or the higher levels of the industrial control systems environment, as well as dust tunnel being able to deliver the C2 mechanism, receive new commands, and implement those on the Windows devices. The next stage down there is where it gets more interesting on the stage 2 components there. So Mousehole, all three, Mousehole, Evil Scholar, and Bad Omen allow for the enumeration of these devices that are within the industrial environments, as well as increasingly the manipulation thereof. Now the challenge of attacking industrial control systems environments in general is that you have to understand what that industrial process is doing and how to change it. So certainly, if you just prayed and sprayed with OPC and doing a bunch of writes across a bunch of devices, you may have an effect, but you'll have no idea what that effect is or if it's meaningful in any substantial way without understanding the industrial process behind that and what it is. So a more graphical representation of what that this sort of scenario would look like. Dust tunnel on the enterprise side, level 4, which is the more enterprise network. Mousehole being ideally suited for level 3.5, which is where a lot of the software aspects that need translation occur in that level 3.5 or level 3. And then as you move further and further down, you can see how Evil Scholar and Bad Omen are gaining access to PLCs as well as safety equipment that can be used and manipulated. I'm not going to go through the recommendations. All of Chernovite and the Pipedream malware capability is not only the 7th malware that has these capabilities, it's the one that has the most depth of capability, the most understanding of some of these protocols and what they signify, but also has the most breadth of being able to attack a numerous level of PLCs rather than one particular model, one particular make. Some of the libraries that it focuses on with CodeSys, which is the kind of the development environment that would be embedded on these PLCs. It is used much more broadly, as I said, than Schneider Electric. It is used across hundreds of manufacturers. So really, it only takes some minor tweaks to have a large impact across these PLCs. And additionally, the grid here is the MITRE ATT&CK framework for industrial control systems. And Pipedream represents about 36% is, I believe, the exact number of coverage of all known TTPs for MITRE ATT&CK for ICS. And so that's a broad range of just the tools, techniques, procedures that is being used, that is understood to be valuable inside of the industrial control systems environment. That's a broad coverage and broad capability that they have. There are a number of resources if you are interested in industrial control system space and some of this. Certainly the Pipedream report is available. The year in review, which is what I was going to present on, is also gives a high level view of the trends that we're seeing from a vulnerability perspective and threat perspective, and then the ICS cyber kill chain, which was quite a bit old at this point, but it was written by Mike Asante and Rob Lee in 2015. Has more or less stood the test of time from a good model of looking at what these intrusions look like from an ICS perspective. So that is my talk. I'll welcome the B-Sides. Glad to be here. I hope this added some flavor for y'all. Appreciate it.